He's a rocket and he's ready to go, cause now the countdown has started and he's ready to blow. He's got the dope sounds bumping and his stereo. That's fast, putting on the show. Don't wanna get yourself together, there's no time to rest. And if you put the time in, he'll put you to the test. He's like a running man and his world war is less. And if you wanna test him, best with your best. Don't make me spell it out.
Mister, I'm sorry, So class, like I said, today we'll be talking about the exponent laws. Mr. John, care to explain why you are 2.2 to the power of 2 minutes late to class? And how you have managed to almost cause a level 3.38 earthquake upon entering the classroom? Sorry everybody, sorry. Okay, now settle down. All of you, settle down. My God, now we have wasted 2 to the power of 3 minutes of class. Do you know how much that is? That is 8 whole minutes. This is unacceptable. Now let's get through with today's class so I don't have to put you three, yeah, I'm talking to you, to detention for the next week. So, focus up. Exponent laws. How many laws are there? There are 5 exponent laws. And in today's lesson, we are going to be diving into each and every law, providing 2 examples to show and check for your understanding. Okay class, so the first of our 5 exponent laws is the product rule. A product refers to what? A product refers to a multiplication question. A product is the result of a multiplication question. So you might be asking now, how is there a specific exponent rule for multiplication? Well, allow me to show you. And this rule makes it way easier when solving exponents in a multiplication question. So for example, here we have 5 to the power of 2 times 5 to the power of 3. Well, by looking at this equation without knowing the rule, off of the top of your head, you would think, well, I would do 5 times 5, which is 5 to the power of 2, which would be 25, and then 5 to the power of 3, which would be 125, and then I just multiply them together and voila, I have my answer. But this may seem like the correct way, and it is actually correct, but there is a way easier way to solve your product exponent questions. Okay, so here I have 5 to the power of 2 times 5 to the power of 3. What I simply do is I just add my exponents. Here I have 5 to the power of 2 times 5 to the power of 3. I just add. Okay guys, so before moving on to the next exponent law, let's solve another example on the first exponent law. Okay, so here I have 8 to the power of 8 times 8 to the power of 6. So what is the first step, or what is the first thing I'm looking for? So the first thing I'm looking at is the bases, to see if I have the same base or not. And in this equation, I have 8 to the power of 8 times 8 to the power of 6. So yes, I do have the same basis, which is 8. So this base will just carry on into my answer here. And the next step, or the second thing I'm looking at, is my powers, or my exponents. So here I have 8, it's a to the power of 8, and I have 6 because it's a to the power of 6. And I just separate those on their own. And I see that my equation is a multiplication question, and I know automatically to add my exponents. So it's 8 plus 6, and as we all know, 8 plus 6 equals 14. So my final answer is 8 to the power of 14, of course, in exponential form. So 9 minus 3 equals 6, which is the result of subtracting my exponents. So therefore, my final answer will be 7 to the power of 6. Okay class, so now on the topic of the power to a power rule, let's take this example. 8 to the power of 8 times 32 to the power of 2. Now you might be a bit confused. Mister, how is this a case where I could apply the power to a power rule? Well, in order to simplify this equation so I can solve it easier for myself, I grab my handy dandy power chart and I will see if I can locate each of these bases under the same base. So here I'm scanning through my powers chart. I can see that 8 is under 2 to the power of 3. So I just write that down here. I have 2 to the power of 3. And then I skim through it searching for 32, still under the base of 2, because like I said, both bases need to be under the same base. So here I'm looking, yes, 32 is equal to 2 to the power of 5. So here times 2 to the power of 5. But hold on. Where did my original 8th power and 2nd power go? I can't just leave them. Well, what I do is I put exponent law, which is negative exponents. Okay? So now let's take an example. If I have, let's say, 11 to the power of negative 7. A lot of you would just say I would do 11 to the power of 7 normally, and I'll just put a negative sign at the end, or at the start of it, I mean. But I'm sorry to tell you that that is completely wrong. Erase that from your mind. Just erase that. Okay? The correct way of doing it is that I'm going to be doing the reciprocal of this number, and this negative exponent will switch to a positive, meaning that any whole number is over 1. So by switching it to the reciprocal, I would have 1 over 11. But where did the exponent go? Like I said, the exponent turns into a positive. So it's 1 over 11 to the power of positive 7. Again, it's 1 over 11 to the power of positive 7. Why is that? Because it's 11 over 1. I did the reciprocal. I just switched them around. So I have, but I can't just leave my exponent behind. So I carry it over with my 11. And because it's the reciprocal of the number, it switches to a positive exponent. So therefore, it's 1 over 11 to the power of 7.